Okay, hey, listen, good morning, everybody. Welcome back. We have Marcus in attendance. Marcus, say hi to everybody.
Hello.
All right, good. Now let's go ahead and let me share the screen. Today it's actually going to be about let's see. Let me double check. Oh, it's this one. Okay. We're actually going to be looking at data, and make a better interpretation of what it's trying to tell us and some conceptions we have sometimes. Okay. So, Marcus, go ahead and read what it says first here.
What do you remember about the Olympics? Would you ever want to watch them in person? Why? Why not?
Yeah. So, Marcus, what do you remember about the Olympics?
That they're a really big sport.
Okay, so big sport, and uh, would you ever want to watch them in person?
Oh yeah,
Yes. Why? Why?
because it's such a cool thing.
All right. So
And
you
to see,
think it's
to see people push their bodies to the limits.
interesting,
Yeah.
pushing their bodies to the limits. So you're a yes, right?
Yeah.
Neat. Okay. So with that in mind, um, if you're going to create a scatter plot of Olympia's height, oops, back up, Olympian's height compared to the weight, what would it look like?
Hmm. It would probably be linear, right?
Well, when you mean linear, like what would you expect? Like, let's say this is 0 pounds, this is 0 pounds, and then this is 0 height. What would you think happened? And let's say that, what do you think the most heaviest Olympian weighs?
Probably 300 pounds.
Okay, so maybe 300. It might be more actually than that, but let's just put 300 as a reference point there, right? Okay. So, and then what do you think the lightest weighs?
120.
Maybe 120. Okay, good. So let's start with the 120. If you're looking at 120, what would you put the height of that person at?
Maybe 5'4".
Okay, so then maybe 5'4", right? Okay. And then what happens is they're growing weight, so let's do 200. What do you think is going to be at 200?
Maybe somewhere around like 5'10".
All right, so maybe 5'10". So I would expect that there'll be some people that in 120 are going to be a little bit smaller, right? And then
Mm-hmm.
some that are going to be a little bit heavier, correct?
Yeah.
And then you would have this still. So I would assume this, right? So even at the 200, there'll be some people that go a little bit higher, a little bit lower, right? So you would have something that, and does this make sense to you?
Yeah.
Yeah, right? Okay, so is it linear though?
Yeah, I think.
Well, in a way it is, in the sense that there is a proportion. That means that you would expect the more somebody weighs, probably the taller they are, right? If you're an Olympian,
Mm-hmm.
just out of natural, because the less they weigh, the lesser height as well, because there's a proportion there. So
Yeah.
there is something to what it is. So let's actually uh, let's actually see what it really was, and that's on the next slide. And take a look. So what do you think? That's what it looked like.
Yeah, see that? We got it right then, right?
Well, we're not that far off, right? Well, that's
Mm-hmm.
and that's because we made inferences in that direction. Does it make sense? We made inferences in that direction. That's how we did it. All right. So with that in mind, let's go back over here and let's so using let's list about the graph as you can. So what can you tell me about this graph?
It's linear.
Okay, so actually there's a better word. It's not so much linear. It's called It's a direct proportion.
Direct
Or
proportion.
yeah, it's directly proportional. That means that the more somebody weighs, the more that they actually, the higher, the taller they are. And it goes with life, you know. That's, I remember that I described that. Another thing that's very interesting that's directly proportional is the service you do, your rewards in life. Okay, the more service that you do, the greater your service, the greater your rewards. And this could be monetary, it could be just quality of life, it could be anything, but the greater your service, the greater your rewards. And the thing that's kind of interesting in this aspect is that sometimes the people you serve, it's not the people that reward you, is other means that you get it. But no matter what, the more service you provide, the more rewards you're going to have. And you can see this anywhere, you know, everywhere that you drive, anywhere that you see, you will notice people. There was people there that provided a service. Every road that we're on, everything that you use, we're so interdependent. Now imagine if you had to come up with your own toothpaste. What would you would have to? It would take. Now think about just the time involved coming up with your own toothpaste. Um, there's somebody that made that service for you that is being rewarded because they provide that service for us. Anything in life, the saxophone you use, uh, the water that comes to your house, everything was created with somebody's idea, and they provide that service, and thus are being rewarded for it. So the greater the service, the greater the reward. Uh, so never, and I know that sometimes there's people that are like, hey, I'm not going to do that unless they do something first. Well, uh, I never seen people get rewarded without doing something. Does it make sense?
Mm-hmm.
Like I've never seen somebody be get rewarded. It's like people say, well, once they pay me more, then I'll work harder. You know, it doesn't work that way. You got to work hard, and then you get rewarded for the work that you do. You know, so just know that no matter what, you will be rewarded. Okay. So, but give me some match apart from directly proportional. Give me some other things you want to describe about this.
It's positive.
Yeah, it's positive. Good. And what about and I think what they're trying to get to on some of this stuff is that there's you want to make sure that you remember that there's an x-axis, y-axis, there's an independent variable
Oh yeah.
and a dependent variable. There's also, is there a title on here? Yeah, there was a title. So I think these are the things that they want you, and there's also scales. Everything was scaled. There's all these things with regards to it, right? Okay, good.
Mm-hmm.
So I think those are the things they want you to remember. So you always keep that in mind when you're looking at a graph or making a graph. You can make your own graph, but knowing that you have to have some of these components in it. All right, so now let's go on to the next one. And, oh, not this one. We did this one. Okay, so now this one is shop till you drop. All right, Marcus, so go ahead and read what it says here.
Researchers want to know if the time spent in shopping malls affects the amount of money people spend. Below is a table of data they have collected.
All right, good. So let's look at the data. All right, so Marcus, look at the data and tell me some things you notice. And then tell me some things that might be missing here that we should maybe add.
There's no independent or dependent variable.
Actually, they are, but they didn't get listed very well. See how there's missing hours?
Okay, yeah.
And there's money missing over here, right?
Mm-hmm.
Okay, um, so I want you, if you're writing the notes, I want you to create this scatter plot. I want you to write it down so you could, remember a couple of things as far as like title. And then the other thing I want you to do is write title here. Still catching it. Title. I want you to go ahead and write it y-axis and x-axis. And that this is your independent, and this is just for practice your dependent variable. All right. Um, so Marcus, what can you, when you're looking at the graph, what can you conclude about it though?
It's like slightly directly proportional.
Yeah, I think that there's still a correlation. And I think
Mm-hmm.
there was more people that were researched because you got to think that there was maybe only, like if we count the number of spots up here, or
Yeah.
there's only like, what is it here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people that were researched, right? Now,
Yeah.
if we brought that into like hundreds of people or a lot more people, I would expect something like this, wouldn't you?
Yeah, exactly.
Maybe some more over here, but you still had the majority that will fall inside it here. So you would still have this thing that's directly proportional. And then, as always, you will have these outliers, kind of, people that just go and they'll spend, they may not look a lot, and they'll spend a lot of money, or people that will not spend, or the other way around, they'll go just to the stores and look a lot, but not, not spend anything as well. All right. So let's go ahead. So which is the independent variable then, Marcus?
Okay, so the independent variable is the hours, and then the dependent variable is the money,
Yeah. And how did we know?
because the hours is on the x-axis.
Yeah. Yeah. And then remember what we talked a little bit earlier, or about how time is one of the most valuable assets we have. Actually,
Mm-hmm.
it's the most valuable because we can't make more of it, we can't save it, we can't do anything with time. So because
Yeah.
of that, we discovered that it's one of those things that leads a lot of things. It just flows into, and the way we know is exactly what you're saying. X-axis and y-axis. There's one thing that comes first and then the other thing second. Now, what's the domain and range of this data?
Oh, okay. So the domain would be 1 to, what is that? 10, right?
Okay, so the domain, actually, you know what? In this case, this is kind of interesting. The domain, you notice how they're just dots on the
Mm-hmm.
graph? Okay, so your domain is going to be all x values. And you see this little sign right here?
Yeah.
That exist inside a specific range set. So like, you see all these x values we have here of time? One,
Yeah.
two, I think these, no, they have 3, right? But you see how they skip 4 in here? I don't see a 4.
Oh, yeah.
Yeah, right? There's no 4. Is there any other number they skip? No, I think you see the rest.
Yeah.
No, the other
They
ones
didn't
are
skip
there, right?
any
Right?
numbers.
Okay, so you would say 1, 2, 3, skip 4, 5, 6, 7, 8, 9, and 10. And then all the y values will be everything that is, in this case, everything else. Oh, so in this one we have a little bit more to write. We have to write down 10, and the lowest after that, 10, 20, 30, 35. Actually, no, there was 10, 15, 20, 30, 35. What else do we have here? 30, 35, 40, and then 60. And we jump, let's go back. Now I'm looking at the money values, 80, 85, and 100. Marcus, why did I write them like this?
Because you asked for domain and range.
Yeah. So this is domain. So in range, but there were specific amounts, like specific. You see how I wrote it in a set? Because I'm
Yeah.
specifically saying these are the things that exist here. I can't say like, oh, it's from 1 to so and so. I could in a sense, but then I'm saying that there's points there, and that's not
Yeah.
true. If there was a line like this existing on here, then yeah, I could tell you, yes, you could say from 1 all the way to here and all the points in between. But in this case, I can't really say that. All right, good. So it says right here, if a person spends 8 hours at the mall, how much money do you predict they would spend?
Okay, so let's go see.
Yeah, so what do you
8
think?
would be around like 60.
Yeah, you're definitely right. Because I think if you draw that trend line, you see that they call that a trend line, you're right around $60. So I would say that you're pretty much right on for $60. And that's because,
Of the trend line.
yeah, because of the trend line. It says now, if somebody spent $50, how long would you expect that person to be at the mall?
$50. So
Yeah.
that would be 6 hours.
About 6 hours. Remember, we said that at 6 hours. Yeah, 6 hours. Something happened. I didn't expect 6 hours. Cool. Yeah. And same thing. Why? The trend line.
Because of the trend line.
Like that. All right, good. Now let's see if there is something else. Okay, now let's look at this graph. All right, so Marcus, read what it says here.
Looking at the graph, write a statement that could describe what this data represents and how it can be useful.
All right, good. So, Marcus, we'll look at the data, and then tell me what do you think it represents.
So it represents temperature and ice cream sales.
Yeah. So, what do you think? Tell me some things you noticed.
The higher the temperature, the more the ice cream sells.
Yeah, and what temperature do you
Directly
think is higher?
proportional.
Yeah, it's
What?
direct proportional. What do you think? What temperature do you think is they're talking about?
Celsius.
Well, they're talking about Celsius, right? But what does it mean in this sense? Like temperature of the ice cream or temperature?
Oh, it's temperature of the atmosphere.
Yeah, exactly. Yeah, and it's kind of hard, since they put it in Celsius, it's a little misleading to you because you're so used to looking at Fahrenheit. You have the benefit that you know Fahrenheit very well, not so well Celsius. But when you start talking about 26 degrees Celsius, I think it comes out being like somewhere in the 80s. No, the 70s. And then, so it's basically saying, in this case, the hotter it gets, right, the more you're probably going to make an ice cream. And that makes sense anywhere, right? You crave more of something cold when it's so hot outside as a result, right? So you're right, Marcus. Data represents how hot things are in regards to hot and or temperature, not hot, just temperature and ice cream sales. Ice cream and money and ice cream. Okay. Now go ahead and describe the correlation. Well, I think you said it right. You said it was directly proportional, correct?
Yeah.
Proportional. Okay, now go ahead and say, now which variable is the independent variable and the dependent?
Okay, the independent variable would be the temperature, and the dependent variable would be the ice cream cost.
Yeah, so temperature is the independent variable, and the dependent variable is the not ice cream cost, but the sales.
Yeah.
Sales of ice cream.
Right.
And how do you know?
Because they're on the X and Y axis.
Yeah, x-axis and the y-axis. And in this case, what is the domain and range of this data?
Okay, so the domain would be 12, 14, 15, 16, 17, 18, 18.1, 19.5, 22,
Okay, and I'm
22.
gonna write, hey Marcus, I'm gonna write 3 dots because it goes into like a bunch of,
Yeah.
singletons, a bunch of singletons. And then Y, same thing, we'll just list a few. We'll list like 200, and that might even be 200, right? But you get the idea that you have single little spots that
Yeah.
represent stuff inside the graph. All right. And it says if the high temperature for day 30, how much money do you predict shop will make? So it says if high temperature for day. Oh, okay, no, this is basically saying if let's say it's 30 Celsius. Let's go back to the graph. So if it's 30 Celsius, how much money do you think it will make that day?
Or maybe $800.
Yeah, maybe 800, right? Because if you look at the trend line, it's kind of like going up, right?
Mm-hmm.
So let's put about 800. Oh, hold on. Same thing before. Bring this down. And if the ice cream shop has a total sales of 500, what do you expect? How hot do you think it was outside?
18 Celsius? Wait, no, 20 Celsius.
20 Celsius. So maybe about 20 Celsius, because then you look here it's about there, right?
Uh-huh.
Yeah, so 20, yeah, 20 Celsius. That's because you look at the graph, trend line. All right, good. And that's it for us today. All right, Marcus. So everybody, thank you for joining us again. Everybody go say bye.